Physical science people, welcome, welcome. This is a video for naming ionic compounds part 2. If you missed part 1 of the video where we went through ionic compounds with a metal and a nonmetal using these first two rules, then you should pause this video and go back and watch that and make the first part of your booklet. We're now going to make the rest of our booklet, and that's this part on the front still. Excuse me. Our booklet right now, when it's closed, when you can see the outside only, not the inside, which we haven't done yet, this is for naming ionic compounds. So you got to have a metal bonded to a nonmetal in almost every situation to use these rules, okay? The last part of this is rule number 3 that is conditional. Sometimes you'll use rule number 3, other times you won't use rule number 3. So here's the if, okay? If you have a metal that has more than one possible charge, okay? So if the metal has more than one charge, okay, then what are we going to do? More than one possible charge. What does that even mean? Well, these atoms up here, okay, these elements, lithium and potassium and magnesium, always are looking to get rid of the same number of electrons. If you think of Kings and Beggars, the game we played, they're always trying to get rid of the same number of gems, okay? There are some metals on the periodic table that we have been avoiding a little bit that sometimes want to get rid of one gem or one electron. Sometimes they want to get rid of 2, sometimes 3. It's not always the same. And these are the tricky ones. So when you come across one of those, if that metal has more than one charge, more than one possible charge, then what are we going to do? In that case, you must use a Roman numeral. And that Roman numeral is going to be used to represent the charge. All right? Now, if this right now sounds very strange, then you are probably a very normal person. This is a little strange. Let me give you some examples. We'll put our examples over here, all right? A lot of our transition metals in the heart of the periodic table are just like these. They are variable charge, meaning that sometimes they want to get rid of 1 valence electron, sometimes 2, sometimes 3, in some cases even 4. An example of that is iron. Iron is Fe on the periodic table. Iron sometimes will get rid of 2 valence electrons and leave it with a charge of +2. Or, in other situations, iron will get rid of 3 valence electrons and have a charge of +3. It could be iron +2 or iron +3. So depending on which one is part of our bond, we have to use a Roman numeral to represent if we're dealing with iron that got rid of 2 valence electrons or iron that got rid of 3 valence electrons. Okay? Mercury is another one of these on the periodic table. Hg is the chemical symbol for mercury. Sometimes it gets rid of 1 valence electron and it just has a charge of +1. And other times, mercury will get rid of 2 valence electrons and have a charge of +2. Okay? So when mercury is part of the compound that we're trying to name, we have to put something in the name that represents which iron or which mercury or which copper we're dealing with. So if we ever use iron and it's iron +2, iron that's gotten rid of 2 valence electrons, then when we name it, we apply rule number 1, which is write the name of the metal first. Okay, in this case it's iron. But then we have to put a Roman numeral in there to represent which iron it is. We'll put in parentheses, and a Roman numeral for 2 looks just like that. It'll be iron 2. That will let us know that it's iron 2 we're dealing with. Okay? If by chance we're ever dealing with iron +3, rule number 1 still applies. We write iron unchanged, but then we would put a Roman numeral 3 in the name to represent iron 3. Okay? Same thing with mercury. If we were dealing with mercury that got rid of 1 valence electron, then the name would be mercury with a Roman numeral 1, just an I right there, versus mercury that got rid of 2 valence electrons and had a +2 charge, that would be known as mercury with a Roman numeral 2. All right? Once you get that name of the metal and the Roman numeral in there, then you apply rule number 2 just the same. You'll add the IDE ending to the non-metal name, and you'll have the full name of a molecule. All right? These are the problems on your naming compound worksheet that are not circled. We asked you to stay away from those at first. Now you can go back and answer those. And I have a separate video that shows you how to figure out whether it's a +2, a +3, a +1. So if you get stuck on those on that worksheet, you can watch that additional video to walk you through that process, okay? This now is everything that we need on the front of this naming booklet. For ionic compounds, whether they have a fixed charge or whether they involve metals that have a variable charge, and there are more than this, okay? You can use this booklet to come up with a name. One last thing, how will you know if the metal you're using is a variable charge metal? We have a list for you, so we will tell you. You won't have to memorize those in this class. You might have to in your chemistry class. All right? Have a great day.